Good afternoon. So we are going through the learning rules of neural networks. In the today's session, I will see another type of learning rule of neural network. That is third learning rule of neural network. That is competitive based learning rule. So the name itself it suggests that it has some competition among the neurons, output neurons. Based on that, this learning method will be worked out. So what is a basic definition in neural network context is the output neurons of a neural network compete among themselves to become active or fired. Means input layer, output layer. There are two layers. If you are neglecting the hidden layers, anyway the output neurons of a neural network will compete among themselves, and any one of the output neuron should be active, or another way you can say that is fired. So only one neuron at a time it needs to be active. So only one neuron is active at any time which won the competition. Among the all output neurons, only one neuron will give the output for the input layer or input vectors or input classification. Will give only one output neuron will be get fired, so that we will get one classification. For example, if again another set of inputs, there may be competition again among the output neurons. Next time a different output neuron will get fired, so that different classification will be there at the output. So that's why it is used to classify a set of input patterns. I hope you understood. That means what I'm trying to say is here, first set of inputs need to be categorized, or it will be grouped into some classification. Let us say the classification is C1. So to send all those input data into the C1 classification or C1 group, all the output neurons will be in the competition, and based on the input data to which classification the corresponding data need to be sent, that will be decided. And in this competition, output neurons will compete one another, and let us say third output neuron has won that competition, and only third output neuron will get fired, so that all the first classified input data will be sent into the C3 classification corresponding to the third output neuron. It will be C3 classification. The C3 classification will be the first input set of data. Let us send next classification, next input data, next all input vector from x1 to xn. All the data you were given again randomly, that weights are adjusted, weights were given randomly, and corresponding to that again the competition will begin among the output neurons. The output neurons will be compete. This time maybe first neuron, last time it was third neuron get fired as it won the competition. This time first neuron may get fired because it may won the competition, or fifth output neuron. So the corresponding classification may be C1 or C4. To that the corresponding second set of input data will be sent. So that's fine. This competitive neural networking rule will be used to classify a set of input patterns. It is used to classify a set of input patterns. So if you see the simple architecture, so this is a how that competitive learning rule will work. We'll see with this architecture. On the left side you have source node or source layer. So the corresponding vector is x1, x2, x3, x4. That is the input vectors. x1, x2, x3, x4. The corresponding output layer is, let us assume this is single layer neural network, and in this the output layers are output neurons. The output neurons are circled ones are the output neurons. There are 3 circuits, those 3 are the output neurons. From the input to output neurons there are connections. From 4 input layers or 4 input vectors, all the output neurons are connected. X1 is connected with the all 3 output neurons. X1 is connected with the first neuron, X1 is connected with the second neuron, X1 is connected with the third neuron. In a similar way, other input vectors also connected with the output neurons. Again, similar way, X2 is also connected with the all 3 output neurons, and so on. X4 also is connected with the first neuron, second neuron, third neuron. Those lines indicate that connections, right? And it has some weights on that connections. Those weights need to be given randomly initially. Apart from this input layer to output layer connections, there are other connections also which are indicated with red line. So those, if you see properly, you observe that architecture properly, there are connections from first neuron to second neuron. On the left side red line is indicates that first neuron to second neuron there is a one connection. Again from second neuron to first neuron the connection is there on the right side inner arrow with red color. In a similar way, second neuron to third neuron and the third neuron to again second neuron connection is there. That arrows, you see properly that arrows which indicates that, and first neuron to third neuron also there is one connection, that outer two big half circles with red line. First neuron to third neuron, again from third neuron to first neuron. So it indicates that red lines indicates that each output neuron also connected with all other output neurons to share the data. First neuron is connected with the second neuron as well as the third neuron to send the information to the second neuron as well as the third neuron. At the same time, to receive that information from the second neuron as well as third neuron, the same first neuron is connected with inward arrows. So here we see properly the output neuron has few input arrows as well as few output lines also. That input lines as well as the output lines will receive the information or to send the information to the other neurons. Okay. So this is a simple architecture. Based on this only the information will be shared from one output neuron to other output neuron, and based on that this competitive learning rule will work out. You see that basic elements in this learning rule, a set of neurons that are all the same except for some randomly distributed synaptic weights, and which are therefore respond differently to a given set of input patterns. That means all the synaptic weights will be initially randomly assigned. Next time again another new set of input vectors means based on that again new randomly assigned input weights will be assigned, but output neurons will compete and only one neuron will get fired corresponding to the weights. Again that weight adjustment will be there, but initially random weights will be assigned. That's what it means. So based on that only the given set of input patterns will be fired any one of the neuron at a time. Single time at one moment only one neuron will be activated. All other neurons will be keep quiet or it will not get fired. In that computation, which neuron wants that computation, that neuron alone will get fired. And also a limit imposed on the strength of each neuron. So there will be a limit also. We need to impose some limit on the strength of each neuron. So that will be while assigning the randomly assigning the weights, we need to impose some limit also. And also a mechanism that permits the neurons to compete such that only one neuron is active at a time, and it is called the winner takes all neuron. Winner takes all neuron means which won the competition, that will take all the input data. That means that is the winner takes all neuron. So such mechanism is developed, so which will permits that only one neuron need to active at a time. So which will won that competition, that neuron alone, it will be in the competition and it will won that competition, and so that only one neuron is active at a time. So this is the basic elements and basic functions of that learning rule. You see the mathematical expression for that winning criterion. For a neuron K to be the winning neuron, its induced local field Vk. Induced local field means, I think, output of the neuron. Output of the output layer is nothing but induced local field. So that will be connected again to the activation function, then that will be the overall output, right? But here, for a neuron K to be the winning neuron, its induced local field Vk. Vk in the basic structure we have seen that Vk, right? So Vk means the output of the output neuron. The output neuron again, it will be connected to the activation function, then summer will be there. So all those are the to get the overall output. Even it is called we'll connect that some bias also. So all those will come after output neuron. Even at output only we can connect that bias also by including the input neurons itself, input layer itself. But here, what is the local field means? The output of the output neuron is nothing but induced local field. That is represented with Vk. Vk for a specified input pattern X must be the largest among all the neurons in the network. That means if you see that expression, Yk is equal to 1 if Vk is greater than Vj for all j values, where j is not equal to k, 0 otherwise. What it means, let us assume j is varying from, you can vary the j from 1 to n. Among that, k is also one of the value. It means j is equal to 1, 2, 3 and so on, k and so on up to n. So if output Vk value, let us take the kth neuron. Instead of taking first neuron, second neuron, I am considering kth neuron. But that neurons, all the maximum neurons are n neurons. The kth neuron output value or local induced field is nothing but Vk. That Vk should be greater than Vj means you substitute the j is equal to 1, j is equal to 2. Vk should be kth neuron, Vk should be greater than V1. Then it will be get fired. All outputs of the neurons will be compared with other outputs. In the architecture also we have seen all the outputs are connected with one another to send the data as well as to receive the data. Based on that, this comparison will be done. The kth neuron, let us take kth neuron is compared with the first neuron, j is equal to 1, j is equal to 2, j is equal to 3 and so on. J is equal to k also we may get, but this condition is not for j is equal to k. That's why yk is equal to 1 for all j except j is not equal to k. J should not be equal to k. Even it will be compared with Vk is greater than Vn also. The local induced field or output, the neuron output should be more than the other neurons output. Then the corresponding neuron will get fired, kth neuron will get fired, otherwise it will be 0. Then the second neuron, let it be instead of kth neuron, go for another neuron, maybe k plus 1 neuron. or second neuron or first neuron. That will be compared to the all other outputs of the neuron. If first neuron output is more than the all other outputs, then first neuron will get 5 and all other remaining neurons will be get 5. So that's what this indicates. Overall output yk is equal to 1. Whether it is getting 5 means 1, 0 means it is not getting 5. So here Vk represents the combined action of all the excitatory, which means feed forward connection, and inhibitory feedback inputs to the K. K is nothing but kth neuron, right? So what is excitatory, inhibitory? If you go back to that architecture, so here feed forward is nothing but excitatory, feedback is nothing but inhibitory. So all the neurons all the connections which are coming towards that output neurons, output circles is nothing but neurons, right? So all the connections which are coming towards that output neurons are called the excitatory connections, or excitatory signals, or excitatory links. And which are going out from that corresponding output neurons are called the inhibitory connections. It means here if you see from the input layer x1 to all the three connections are going towards the neurons, output neurons. That means those are the excitatory connections. But if you see the red color lines, there are two lines which are going out from the first neuron. One is going from red line is going from first output neuron to second output neuron, and another one is going from first output neuron to third output neuron. One is on the left side, one is on the right side. Right side bigger off circle is going from 1 to third. Those are called the inhibitory connections, or inhibitory links, or inhibitory inputs, which are having arrows towards the output neuron is nothing but excitatory, which are having output towards the outside is nothing but the, which are giving or sending the information outside is nothing but the inhibitory connections or inhibitory inputs. So that's what it indicates. Here Vk represents the combined action of all the excitatory. Combined action means all the information is receiving towards the output neuron with the excitatory connection, right? That is nothing but feed forward connection, and also with the feedback connection, which is nothing but inhibitory or feedback inputs towards that kth neuron. So at kth neuron, that Vk represents the combined action of all the connections, whether it is input or output. If it is input means excitatory or feed forward. If it is output means inhibitory or feedback connections. So based on that, this all the information will be received from the all other output neurons, and it will be the combined output. That is nothing but yk. The yk, it will become 1 when the corresponding kth neuron output is more than the all other neurons output, based on the received information from the inhibitory as well as the excitatory connections. Okay. How that weights will be updated here. So randomly we will assign some weights, but that weight needs to be adjusted. So to adjust that weight according to the standard competitive learning rule, the change in weight is defined as the change in weight here, del wkj is equal to neta into xj minus wkj. If k wins, if kth neuron wins means we need to, the difference between the xj input, xj is nothing but input, right? Jth neuron input, and the jth vector is connected to the kth neuron. That's why the corresponding connection link weight is nothing but wkj. So we need to subtract that connection link weight wkj between the jth vector to the kth neuron from the jth vector input. Xj minus wkj will be multiplied with the learning rate parameter if k wins. Otherwise, If k loses, kth neuron loses means the corresponding connection link weight should be 0. Change in weight, corresponding change in weight of the connection link. Initially whatever we assigned the weight will be as it is, there won't be any change in the weight, del wkj. If any change in that weight del wkj need to be added with the initial weight. Initial weight, let it be wkj will be added or subtracted with the del wkj. That we know, right? Change in weight means only change in weight we are finding out here, but this need to be added with the corresponding initial weights. That is a weight updation, right? So here neta is the learning rate parameter and xj is the jth node input. Wkj is the synaptic weight from the jth node to the kth node. So generally Wkj, kj will represent, but that is a connection link from j to k, even though that is represented with the Wkj. K is first subscript, j is second subscript, but there is a synaptic weight from the jth node to the kth node. The representation in the neural network is like that only. Wkj represents the connection link weight from the, which is from the jth node to the kth node. So in this way the weights need to be adjusted and the process will be continued. Only one output neuron will be get activated at a time, which will won the competition. So thank you.